All right, today we are on 4.9, function notation. So remember, a function is just a rule that assigns each input value exactly one output value. So an analogy for this would think of it as a machine that takes an input and produces an output, kind of like a vending machine where you type in a code like B4 and you get out whatever food is assigned to B4. So like Skittles, you plugged something in and you got one thing out. You wouldn't get a bag of Skittles and M&Ms out by plugging in one thing. So if we plugged in x equals 4, we'd plug in 4 for the x, square it, and we would get out 16. So we're going to use this function machine to answer the following questions. If the value x equals 3 is put into the function, what is the output? So I'm going to input x equals 3. I'm going to plug it in for the x values. So y will equal 3 squared plus 2x. 2 times 3, I'm sorry. And then I can solve for y. So y will equal 9 plus 6. So altogether y will equal 15. That's my output value. Now, going backwards, if the value y equals 3 comes out of my machine, what was my input? So I'm working backwards. In this case, I'm going to plug in 3 for y, and I'm going to solve for x. So I have an x squared plus 2x. It's kind of looking like a quadratic. Not totally, because I still have a 3 on one side. So I'm going to move the 3 to the other side and set it all equal to 0. So I'll have x squared plus 2x minus 3 equals 0. I can then factor. So x. My signs are going to be opposite, and the bigger number is going to be positive. So the only numbers that multiply to 3 are 3 and 1. So we'll plug in 3, we'll plug in 1, and the outsides plus the insides equals my 2x. Perfect. And then I need to finish solving. So this all equals 0. So x will equal -3, or x could equal 1. Now, what is the smallest output value that this function can produce? Consider the graph of the function as a parabola that opens up. Okay, so parabola looks like this. We have our vertex, and this is the smallest or lowest point that we have. The coordinate is x comma y, the x being our input and the y being our output. Okay, so what is the smallest value that we can have here? I think the easiest way is to probably just graph this. So I've graphed it. I found my vertex, -1, -1. So we have when x equals -1 as our input, our output will be, we gotta get rid of that, y equals -1. Okay, perfect. You can read through those notes if you want to. Function notation is simply f of x. So f parentheses with the x refers to the y value that is produced when the x value is put into a function that just happens to be named f. So basically, f of x is the same thing as y. The only difference between y equals 2x and f of x equals 2x is that this has a name. It's function f. Okay, this equation doesn't have a name. Okay, so the example here, the function y equals 5x minus 2 can also be expressed in function notation as, notice the y is replaced with the f of x. Everything else stays the same. This is just a way for us to refer to this function, and it kind of gives it a name. So if you want to refresh your memory, you can. Here's an excellent example where they give you the function f, and they're asking you to find f of 2 and f of negative 2. This is simply just saying when x equals 2, what does plug in 2, and totally separate, what happens when x equals negative 2, and then solve. So here's for f of 2, and did they do negative? Oh, here's negative 2. Okay, so let's look at example number 2 down here. What happens for, use the function g of x. Only difference between f of x and g of x is that we call this function g. So g of x equals x minus 1 over x plus 2, and r of b, this is function r, and the variable that we're talking about is b. So x, b, and b. To find the following values. So for this first one, g of 4, so we're referring to function g, so this one right here. So what happens when x equals 4? So g of 4 equals 4 minus 1 over 4 plus 1, and that will equal 3/5. So if you want to write that out, g of 4 equals 3/5, signifying this was my input, this was my output. Kind of all written in one nice, easy place. Okay, what happens when for g of 1/2? So I'm going to go back to the function g and plug in 1/2 for x. Oops, why did I write a negative? 1/2. So g of 1/2 equals 1/2 minus 1 all over 1/2 plus 1. So that will equal, we'll have negative 1/2 on top, and on the bottom 3/2. Okay, I can flip that around to get rid of the 3/2 on the bottom. So I'm going to multiply by the reciprocal. Oh, the reciprocal, oops. 2 over 3. Okay, so I see how I flipped that. And then now 2 will cancel with the 2, and I will be left with, change my color back, negative 1/3 is my output. All right, next one. What happens for r of negative 5? So we're looking at function r right here, and this time b equals negative 5 because b is our variable. So r of negative 5, I'm going to plug in negative 5 for b. Square root of 9, which leaves me with r of negative 5 could equal plus or minus 3. And then r of negative 15. So again, b equals negative 15. I'm looking at function r. So r of negative 15 equals square root negative 15 plus 14, which will give me a negative 1. I can't have a negative 1 under the radical sign. So my answer for this one is not a real number. This would be an imaginary number, which I know some of you have seen before, but in this class we are not looking for imaginary numbers. All right, number 3. The function h of t equals negative 16 t squared plus 64t plus 80 gives the height in feet of a projectile t seconds after it's launched. Find both h of 0 and h of 3 and interpret your answers. So basically we're finding two different things. So when t equals 0, that means 0 seconds, because t stood for time. We will have h of 0, so it's 0 seconds. How high is our object? So h of 0 equals, that equals 0, that equals 0, so I'm left with 80. So interpreting in the context, at 0 seconds, the height of whatever object I'm looking at is 80 feet. All right, and then we still have to do the second part here for when t equals 3, so that's 3 seconds. How high will our object be? So h of 3, I'm plugging in 3 for t, negative 16 times 3 squared plus 64 times 3 plus 80. Honestly, just plug that into your calculator. H of 3 would equal 128. I just plugged that right into Desmos. Pretty much just like how I wrote it. So this means that at 3 seconds, the height of whatever object we're looking at is 128 feet. And that is it. All right, here is another example if you want to read through that. Let's look at number 4. So use this function machine to find f of negative 6 and x when f of x equals negative 6. So we're finding two different things. We are first finding when x equals negative 6. So I'm going to plug that into my machine, and we'll have f of negative 6 equals negative 2 times negative 6 plus 7. We have 12 plus 7, so f of negative 6 equals 19. Okay, and totally separate, what's the value of x when f of x equals negative 6? So for this one, I'm working backwards. F of x equals negative 6. So I'm plugging this in right here. So negative 6 equals negative 2x plus 7, and I solve for x. So subtract 7 from both sides. I'd have negative 13 equals negative 2x. Divide by negative 2 to both sides, so x will equal 13 halves. Okay, so it's two totally separate problems there. For number 5, the function that we just saw, h of t equals negative 16t squared plus 64t plus 80 gives the height in feet of a projectile t seconds after it's launched. Find when h of t equals 0 and interpret your answer. So first, what does this mean? Okay, h of t is the height in feet of an object. So we are essentially looking for when is the height 0 feet. So So we are going to go 0 equals negative 16t squared plus 64t plus 80. This is a quadratic function. I have absolutely no desires to solve this. I'd probably try factoring out a common number because they all look even, but that's a lot of work. I'm going to use Desmos. So I'm going to type in negative 16x. I don't have t, well, I have t's, but Desmos doesn't recognize t's, so I'm actually going to change my t's to x's. Plus 64x plus 80. I'm going to have to, here we go. Okay. So h of t, just like f of x, is the same thing as y. So we're looking for, on our graph, when does y equal 0? And it's right here. So y could equal 0 at -1, when x equals -1, and when x equals 5. So remember that x was the same thing as t, which equaled time in seconds. So for this first one, it's saying at -1 seconds, and this one is saying at 5 seconds. I gotta get rid of that. The height is 0 feet. Now, at -1 seconds, that is impossible. We can't have negative time. So this answer doesn't make logical sense in the context of our problem. So the only time when this object is at a height of 0 feet is at 5 seconds. So let's see. So that is my answer right there. Okay. Whew. And for our last one, considering the following 3 function machines. We want to find the value of x equaling 5. It's put into the first machine, its output is plugged into the second machine, and the output of the second machine is plugged into the third machine. So what is the output of the third function machine? So basically what I'm doing is I'm plugging in x equals 5 here, and then my answer is going to go here, and then that answer is going to go here. So f of 5 equals 4 times 5 minus 9. So 20 minus 9, that'll equal 11. So now x equals, let's change colors. Okay, so x equals 11, plugging that in. So g of 11 equals 11 squared minus 11 minus 10. So I have 121 minus 11 minus 10. We'll get nice 100. So then I'm going to take x equaling 100 and plug it into my last machine. So h of 100 equals square root of 100 plus 4. Square root of 100 is 10 plus 4. So we'll get 14 as our final output. Whew, okay. You can try part B on your own. I think my video is long enough. If you've got any questions, let me know.